Hi guys, so for the homework, first couple questions are just simply vocabulary. You can learn those from the videos from earlier, hopefully. If you wanted to do this one, A, B, and C are up here. This is A, this is B, this is C. You're just going to match those with these 1, 2, and 3 from over here. Remember, R is equal to 1 would be the straight one, that would be 2. And so you can kind of go through and look at these. The closer they are to 0, the more scattered they are. This one's probably the most scattered of the 3, and so I would say that that one's probably the smallest value, so hopefully you guys can do that. Next, we've got match it with the linear coefficient that's -1. Well, that's easy. That's the linear that's -1. That's this one, and then there's other parts, I'm pretty sure. Oh, that was it. Oh, okay. Will the following variables have a positive correlation, negative correlation, or no correlation? Number of doctors on a staff in hospital and the number of administrators. Obviously, there's probably a correlation, right? The more doctors you have, the more administrators you probably need. So I'd say probably positive correlation. Next, we've got data table. Obviously, go ahead and pick which one's the explanatory and which one is the response variable. And so you guys can go through and do that. This one, they give you 2 charts. Don't forget to look at them. Which variable is the explanatory based on the goals of the research? So, one study, researchers initiated a long study of a population of American black bears. One aspect of the study was to develop a model that could be used to predict a bear's weight. So, I mean, the length would probably be the explanatory. Let's look at their table. Yeah, they have length and weight, so I'm assuming it's that one. Okay, and so draw the scatter plot diagram. To do this, what I personally would do, I'd enter these in the calculator, put them in lists. You can put your list here. These are the response, these are the Y's. This is list 1, this is list 2, and then you can kind of see which one it is. Don't forget to put stat plot on. I'll show that in another part of the video. I would assume the lengths are good. I'm just going to guess right now. I'm not. Oh, I guess right. And then to do this part, all you have to do, guys, is, I guess if you were going to enter this in the calculator anyway. Let's do it real fast. Oops, wrong one. Let's just enter it. We got stat, edit, 138, 135. It's not 138, 138, 5, 130, 120.5, 149, 141, 141, 150, 166, oops, 151.5, 129, 129.5, and 150. Okay, there's list 1. Then we're going to do list 2. That's 110, 60, 90, 60, 95, 100, 95, 85, 155, 140, 105, and 110. Okay, so that's entered. We go ahead and quit that. We're going to go stat, calc, linear regression. I think we can use that to do this. Oh, no. We don't want to do that. We want to use stat. There is a, which one is this? This is not linear regression. This is linear regression test. I think. Yeah, let's try that. Since we're not worried about the test itself, we'll just calculate it. It should tell us. Yes, here we go. Does it say R on here somewhere? There it is. R, 0.7430. 3 decimal places, 0.7430. Okay, and so you can get that. And does the linear relation exist? I mean, if you look, this one's positive because R is positive. The absolute value of the correlation coefficient, 743, is greater than critical value. The critical value here is going to be, how many bears was it? 12.576. Check the answer, and we are good to go. Okay. If the linear correlation between two variables is negative, what can be said? So you guys can go through that. You can answer that. This could be true or false. You can figure that out. For me, on this one, I would put these in the calculator and then solve it that way. Then we'll give you some other questions after. It'd be similar to the one we just did. And for this one, just make note a couple things. So let's see. The age difference is the Y and the literacy is the X. So for every literacy rate, the age difference falls by 0.0534. Okay, we got that one. Does it make sense to interpret the y-intercept? No, because it's outside of the scope, right? So this is between 20, the x values are between 23 and 100. So 0 does not fall in that scope. Okay. Predict the age difference between the husband and wife at 37%. Plug that into this. This is going to be negative 0.0534 negative 0.0534. Oops, I didn't mean that. Crap. Negative 0.0534 times 37, I think it said. Plus 7.5. 5.52. I think it wants one decimal place. Yeah, 5.5. Check it. Good to go. Would it make sense to predict the age between for 16%? Well, 16% is outside of 23% and 100%, so no, it does not make sense. If the literacy rate is 98% and the age difference is 2 years, so plug 98 into that. We got second. Oh crap, it was already up there. 98. Oops. 7.5. That's 2.26 or 2.3. So if this is 2 years, that's below the average. The average is 2.2. Oh, oops. Is it 2.3? Yeah, it's 2.3, sorry. Okay, and then we're done with that. So I hope you guys can get this homework done. I hope you're doing well. This is the last of what we're doing for this stats course. Don't forget to be ready for the final. we'll do a review or something, and I'll get the test up in the near future. And then if you have questions, please email me, get a hold of me, contact me, whatever you got to do, guys. I know this has been a stressful quarter for you guys, or semester, but hang in there. We're almost done with it. Thank you, guys.